Hello everyone again. I hope you're doing well during this Easter weekend. On my end it's a bit rainy, but other than that all good. Today the plan is to cover Memgraph 1.4 release changelog, since we released Memgraph 1.4 this week. So I'm gonna go through the changelog items and try to explain each item in a bit more details, since we try to explain these things in the best possible way, but there is always another point of view. That's one. And the second thing is I extended the Rust query modules code with the code to check is there a label on a given vertex. So I'll just go through that and explain what has been added, but that should be fairly quick and simple. Nothing really changed significantly since the last time. The goal is to be done in 30 minutes, under 30 minutes, to be quick and insightful. If you like this content, please share, like, subscribe in the bottom, and yeah, that's it. Let's jump in. If you have any questions or anything, please put them in the chat, especially about the changelog items, because I'm happy to answer all questions and explain what are the implications of these changes and stuff like that. Okay, I'll go back to my code view. Let me switch here. So yeah, just maybe a little bit before the changelog. So Memgraph binaries are available on the download page. So here you can access all these binaries. We have the builds for all latest like Linux operating systems, and also Docker image for everything else. And yeah, so maybe I can also showcase that. So you can download the image here once the download is done. So I will just explain the Docker download and Docker load. Let's do this here. -e. So once the Docker image is downloaded, you have to load it with this command, docker load -e, and I'll place myself here just since I noticed that we have that logo in the same corner, but yeah, we have to actually change that somehow. All right, so I think it's almost done. Downloads Memgraph 1.4. Yeah, since I have already did that, it just loads the image, and then later we'll run Docker container with that version. Okay, let's jump to the changelog. Changelog can be found on the docs page, on our docs page. So under Memgraph DB there is a changelog, and it explains all the changes that happened in each version. So just to start with, we introduced one breaking change. Essentially, it's not a huge breaking change. We just changed the syntax for setting the memory limit of a procedure call. That's now a lot of information, but essentially, when there is a procedure call, a memory limit can be defined for that procedure call, and we just changed the syntax from memory limit to procedure memory limit to be more explicit, because it's also possible to set the memory limit for a query, so for the whole query. And in order to make a distinction between these two, we added that procedure clause here. So it's not a huge breaking change. Nothing's gonna really break. Only these procedure queries that set the limit, they have to be changed a bit to in order to make them run with version 1.4. That's about it. And now let's jump into the major stuff. The first item is really a huge thing. So we added the whole implementation of our replication to the community version. So the community version now is very well equipped with features that can be used in production, and replication is probably the most important one for production applications, because you want to replicate data across to another, I don't know, a machine or even a data center, so that in event of any crash or something, you have additional instance of Memgraph which is up and running and that can take the application workload. I mean, we added that into the whole community version, and of course, as Dijkstra said, it's impossible to prove that there are no bugs in any software. But yeah, feel free to test it and give it a try, and any feedback would be helpful on that side. And yeah, we are happy to help deploy that and manage the whole thing. That's about replication. And then this one tells about query modules. So we extended let's say the runtime flag query modules directory. So there is a possibility now to define multiple query modules directories, and that's very good because, for example, you have the ability to use all query modules that are coming with Memgraph, or maybe the Mage query modules, all the Mage query modules. But in addition, you can also define additional directory with your own query modules, where there are some custom modules or I don't know, whatever is added for a given deployment of Memgraph. So multiple directories could be defined, and I think that's very flexible. When I was thinking about that, I thought that we should actually add a default into that. We should always add the default query modules directory, but yeah, that might come later. It's with this there is enough flexibility to define anything. Just the ease of use could be improved further. That's about it. That this is very simple. This one is much bigger in terms of functionality. So Memgraph now can load during the runtime. Memgraph can load data from CSV files through the load CSV clause. So you can write load CSV and then path to the CSV file, and then you can compose that with another clauses from Cypher. What I want to say on that end. So I can maybe go to the reference guide and find that. Actually, do we have that somewhere here? Oops. Okay, here we have the exact clause, and yeah, so load CSV from CSV path. This is for now only a local path, so I think we didn't add HTTP network download for now. So yeah, you need to have a file on your local file system, and there is a possibility to use headers as well. So with header, each row will have, maybe I can zoom this a bit. Sorry. each returned row from the CSV will have the header also included, so it's going to be a dict of values. Quote and then variable name, and then this variable name will be variable where each row is going to be stored, and then after that query you can write create a node or create something. So you can use this variable to create data inside Memgraph. Yeah, it has the whole page explains now how to use that, but I won't go into all the details. Yeah, feel free also to write feedback about that. Okay, let's go back to the changelog. That's about CSV. So before this clause, we just had a CSV import tool, but it was the problem with that was that it was only possible to load CSV before actually running Memgraph, which is not super flexible, and you always want to add something more and stuff like that. And this is now a bit more flexible. Of course, it has some drawbacks when it comes to the speed, because all file has to be like loaded from disk, and then the whole pipe, since we support all flexibility of Cypher, the import has to go through all through the entire pipeline of queries, which of course could be improved further, but because of all the flexibility we want to expose, we have to go through the entire pipeline. That's it. And then memory limit. This is also a big deal, because up until now Memgraph didn't have any control of the memory usage. So essentially, if Memgraph run out of memory, operating system would kill an instance of Memgraph, and basically that wasn't great, because you never know what will happen, and then Memgraph becomes unavailable, and this is not great from the application standpoint, because you have to deal with that. With the memory limit, you can set the memory limit of memory usage, and that's great, because after Memgraph consumes that amount of memory, it will stop allowing, it will prevent creating additional data inside Memgraph, and by that instance will be alive, and it will be possible to run read queries, but for additional writes, an administrator has to do something, has to provision more memory, do migration or whatever, but Memgraph won't die unexpectedly. There is a default for the memory limit. I think in terms of if the swap is available, then the memory limit is like 100% of the actual physical memory, and if swap not is available, then it's 90% of that memory. But with memory limit, you can specify explicitly what's the memory limit, and of course that's not. There are ways to break that. For example, if a server has additional applications which consume a lot of memory, Memgraph won't be able to detect that, and then it might, so in other words, it still might happen if Memgraph consumes less than that amount of memory, that Memgraph will crash because there is not enough physical memory. But for the, let's say, recommended deployment, Memgraph should be the only process that consumes a lot of memory on a machine, and then in that scenario it's quite robust and should not break. Yeah, if you have any questions about all this, just put them in the chat. And then we added free memory query, which tries to free unused memory chunks. and you can call that explicitly, and then maybe something will be released. It's quite complex under the hood, so it doesn't guarantee that memory will be freed. But you can do that explicitly, and maybe something will be deleted and released. We also added the memory limit and the amount of consumed memory into show storage info query. So when you run show storage info, then you get info about the memory limit as well. Yeah, this one is very similar to procedure memory limit, because this, in the same way as the procedure call can be limited, the entire query, so memory usage for the entire query could be limited with a given amount. And that's also very nice, because there is always a problem with queries that, I don't know, produce a bunch of results or do some Cartesian-like operations where the total amount of data is fetched at a given time, and then that can break the entire database, which doesn't make sense. And most of the time, a user is not aware of the complexity of the query, and then it does make sense to break the software just because of that. So there is an option to set that memory limit explicitly, and that's, I think, quite good for the operational for dealing with Memgraph in an operational environment. And the last big thing in the features is we added a bunch of logs into the recovery process. So previously, when a snapshot was loaded or the data from disk was recovering, we only had like start recovering and end recovering, and in between it was very blurry what is going on. By adding logs throughout the entire recovery process, it's much more transparent what is going on and in which part of the recovery Memgraph is at a given time and what is going on there. So yeah, that's about major features. And then bug fixes. This is also very interesting because we had a huge bug for a long time with garbage collection. So basically we didn't invalidate one timestamp, or not like change one timestamp, and that resulted in a memory leak, which was only visible when you restarted Memgraph a couple of times. And it was very tricky to detect that bug, but we managed to do that and fix that very easily without any other implications. Fix reloading. Yeah, this one is related to a bug that I encounter also during the live streams, and it's also a very subtle bug with query modules signatures, let's say, with data types and the caching of query plans. The problem is that Memgraph is caching query plans because they don't change. If you have like a query, and based on that query we built a query plan, and that for a lot in a lot of cases it makes sense to cache that, because only the values, only the literal values in the query plans are changed and nothing else changes, so it makes sense to cache. But with query modules there are a bunch of things inside. So we have a return value, parameters of the procedure, and it's quite tricky to detect that a query plan has to be invalidated in the query cache. Because of that, our fix at this point is just to not cache queries that have procedure calls. So these plans are not cached at this point, each query module call will go through the entire pipeline of parsing and planning and all these things, and then will be executed, which implies that query module calls have slightly higher overhead, but I think that's fine because most of these modules are expensive when it comes to execution. So the cost of planning and the parsing of these plans of these queries is minor. At least that's a hypothesis. We'll see about the workloads and usage. If we detect that that we need to cache some of these plans, we'll do so. And the last point, we also fixed the profile query to show the correct name of the scan all operator. So the problem was that the profile command didn't return right results because all scan all operators were presented as scan all, which is not correct because we don't have just scan all. There is scan all by label property, scan all, and multiple versions of scan all operator, and they were all presented to the user as scan all operator, which is incorrect. And we updated that and fixed, so when you run profile, you'll get the correct name of the operator that was executed. So we have, just a step back, we have explain and profile command. Explain command just returns operators that will be executed, and profile returns the exact times during the execution. It actually executes a query and then returns the actual time. Explain was correct, but profile was incorrect. So we fixed the profile one, and that's it. Yeah. One more high-level note is that by adding the memory limit, we actually degraded performance a bit because we have to count these things, and yeah, I think it shouldn't be a big problem, but we have planned to go back and fix these things. For example, these things can be easily fixed for read queries, and we'll do so in further releases. Okay, that's about it. Yeah, feel free to download, test it, and give it a try. Any feedback is welcome, and we'll try to improve further. That's it from the changelog perspective. Okay, I'll now go back to the Rust stuff. Let's go here. So yeah, just to last time I stopped here, migrate to CSTR macro. This time I added add bool result type and vertex has label method. So I'll just showcase what is going on. Where to start? So vertex. So my overall goal is to build abstraction for vertex, so that Rust code can use these abstractions. For example, labels count and has label, and also the goal is to build these abstractions and then use, for example, has label method has the name which is type of str, which is a Rust type, and then you can write pure Rust code to interact with Memgraph. And essentially, today I've just extended this part here. So has label method, and that's it. Nothing else was added. So just what the label is. So label is a synonym would be a tag. So each vertex can can have 0 or multiple labels, and these are, for example, if you model humans as vertices, then each human would have a label person or human, for example, and or you can add additional labels like student, etc. And once you have these labels defined, you can ask if a given vertex has label and of name. In this case, I like the method gets the name, and then since we are dealing with the C API, we have to transform that into the C string, and that's done by calling C string new and then passing name. This has two implications. First is that we need to make additional allocation for that name, because we have to pass that. We have to create a C string and pass that into the engine. I don't think we'll be able to remove that allocation from here, because these names could be dynamic. So you can read a label name from a graph and then call a procedure with a dynamic name. So we can't fix these things easily. Maybe if Rust has some way of transforming this string into a C string without doing allocation, but I have to dig deep into that. I'm not sure about that at this point. And then unwrap, that's standard problem. We have to remove that unwrap from here, because that will crash everything, and that's possible to do. So we just have to change the interface and then propagate the error to the caller, and we'll be good by doing that. But yeah, I've just commented to do here. I'll do that later. So yeah, allocation tricky. We'll see about that. Panic, we have to remove that for sure. And then since Memgraph API has already, so with bindgen we generate MGP label and struct, and that struct already has the C char pointer. We have to create that label struct here, and we are creating it here, passing the C string as a pointer to that struct, and then we can call MGP C function MGP vertex has label, and then we just return that. So basically, let's go here, has label. So this method return non-zero if the given vertex has the label. So if it's different than 0, then we return true, otherwise we return false. That's it. But we also had to add, and then the calling of this is in the following way. So we just have, once we have the MGP vertex, so this is also a Rust struct, we call has label, for example, L3. That's the label that we are checking for, and also once we have the information, we have to create a value. We again have to create value that Memgraph will read and return back to the caller. To do so, we created a function make bool value, which gets bool value and returns and just creates the MGP value out of that, and it returns it. So we create MGP value and then return it to the caller. That's done here. That's the same as with integer here. So that's exactly the same approach. I think here will stay the same like forever. The same concept since last time I managed to create these strings. So in this case, I've actually here we have a static string because we know this message will never change. We'll have that message just like that all the time. So it's a bit different than the hasLabel method. Okay, and make int value, make a bool value, and that. And then the trickiest part is that we have to specify for which result we are creating value and returning value. And then when we inserting the record, we have to be sure that the name is here correct. I think I'm gonna make some abstractions for this because it's very error prone. For example, if we go down here, we have these we have to specify hasLabel here, but also here when we adding that value. And we during the query module during the query module's coding, let's say, the has value would have to be specified a couple of times, and that should not be error prone. This is here a regular string, and we have to somehow put abstractions in place to avoid errors on that end. But okay, and then the last thing also is a procedure. Since we have types for each procedure, we need to call a method that registers the type, and that's done by add bool result type function, which is here. Basically, this is again the same with integer. So here we created an integer result type method, and here we have a bool result type. Sorry, I'm changing all the time method and function. These are functions here, and we also need a function to register the result. And yeah, that's also, so this is kind of boilerplate. So first we have to create the value, then we have to insert the value into the result, and then again before that we have to register correct name and correct type, which is boilerplate and error prone. So my goal in the further videos, further streams, will be to minimize that work as much as possible. And yeah, that's about it. So let's try that. So I'll run the cargo build. I do have some unused methods and functions. The goal, I'll write unit tests for this, and then that will be used and stuff like that. But for now, it's just complaints. But actually, we should remove this here. This is a legit complaint. So labels count is not used, integer result. These are good because these are the library functions that we want to preserve. And then I'll run memgraph. So the code is here. And yeah, we have since version 1.4 we have slightly more insights here. So memory limit is set to 31 gigs, which is okay. I have that amount of memory on my machine. Then we have all these logs. Yeah, everything else is the same. We didn't do recovery at this point, so I don't have much logs about that. Let's go to the lab. If we create these data here, so we have 3 nodes inside, and then we run the procedure. We basically got has label false, false, true, because I test for label L3 explicitly. But okay, that's that's fine. And yeah, that's I think it. Yeah, I slightly overrun again, but fine. No questions. Feel free to ask. Feel free to ask later as well. I'll try to answer. Okay, what else have I forgot? Something I didn't. Okay, I'll close this. Let's go back here. I hope it was insightful, and I tried to explain all these things, especially with the changelog. Like the team made great effort into all of this, so I really hope this is gonna be useful. And yeah, any questions, just ask. Next time I continue with Rust code. Probably I'll really try to finish at least vertex part, so that we can fetch properties, set properties, and stuff like that. Actually, getting the properties is the most important. Setting is not that important, but yeah. And then after vertex, the goal is to have the whole graph abstraction as well. Yeah, that's about it. Have a nice rest of the weekend. And yeah, see you next Saturday. Bye bye.